Okay, this is the solution for a summing amplifier. And we are trying to solve the traditional find the output as a function of the input. In this case, the input is actually composed of 3 different voltages, V1, V2, and V3, and they are all connected to the negative input of the amplifier. I could solve this by assuming 3 currents on R1, R2, and R3, and a current through the feedback resistor, but I will point out that the summing amplifier has a feedback resistor into the inverting input of the circuit, so it is always inverting even when it sums. And I'm gonna solve it using superposition, which is one of the principles we learn in chapter 4. Which means that the output is a sum of the output due to input 1 plus the output due to input 2 plus due to input 3, and I will solve each one of them using the following shortcut. I will draw for the first one here the plus. The non-inverting input is hooked up to ground, so I'm going to assume only V1. What happens is that the 2 and the 3 are connected to ground, and therefore, because this is ground and this is ground, there is no current going through those 2 resistors, R2 and R3. So for the purposes of this first circuit, I can draw it like this, and hopefully you recognize this as an inverting amplifier, so that I know that VO1 will be minus RF over R1 times V1. This is the output due to the first input. By doing exactly the same circuit, I can derive the same relationship between the output and input for the second one. So V2 would have R2 here and RF, assuming R1 and R3 are connected to ground. Now, because I'm turning off these 2 voltage supplies, which means they're shorted to ground, for this VO2 will be minus RF over R2 times V2. In a very similar circuit, except only with V3 will give me VO3 will be minus RF over R3 times V3, and therefore I can conclude from here that I'm going to use those 3 equations here, 1, 2, and 3, into this one. I can tell VO will be minus RF over R1 V1 minus RF over R2 V2 minus RF over R3 V3. More generically, a summing amplifier. Let me change. Has as output minus this 1 feedback resistor times V1 over R1 plus V2 over R2 plus Vn over Rn, where n is the number of inputs, and each resistor is associated with that particular input voltage. This is it.